Today we'll be looking at the angles in polygons, but first we need to work out what a regular polygon is. So a regular polygon is a polygon where all the sides are the same length and therefore all the angles are equal. For example, a regular polygon could be an equilateral triangle or a square because all of the angles, all of the sides are the same length. So when you're doing a question on this, make sure you read that really carefully, because if you're told that a polygon is regular, it makes the method of working this out a lot easier. So we're going to look at interior and exterior angles. The interior angles are the angles that are inside a polygon, and the exterior angles are the angles outside a polygon. Now these make a straight line with the interior angle. So you can look at a straight line and therefore you will know that they add up to 180 between them. So if we combine the two diagrams, you can see there that they're on a straight line, and just mentioned there, they are on 180 degrees as a pair of interior and exterior angles. So if we look at the interior angles of the polygon, these can be calculated by considering how many triangles a polygon is made up of. So if we take here a pentagon, it has 5 sides, and that can be made into 3 triangles. We know that the interior angles of a triangle add up to 180, therefore 3 times 180 gives us 540. And that is the sum of the interior angles of a pentagon. A 6-sided shape, a hexagon, has 6 sides. And in a hexagon, you can fit 4 triangles. Each triangle has an interior angle of 180 total. So 4 times 180 gives the interior angles of a hexagon as 720 degrees. A heptagon, septagon comes from the Latin, however it's a lot more common in geometry terms to use the term heptagon, has 7 sides, and therefore you can make 5 triangles. 5 times 180 equals 900 degrees for the internal angles. Now you can work this out for any sided shape if you replace the amount of sides with an n. So if you replace n with, for example, 10, you could say that n minus 2 equals the amount of triangles you can fit in. So for example, 10 minus 2 would allow you to have 8 triangles. And if you wanted to work out how many degrees there were, it would be the amount of triangles times 180, and that would give you the total amount of degrees on the inside of a polygon. So if all the shapes are regular and all the interior angles will be the same, then we can divide the sum of the interior angles by how many angles the shape has. So a pentagon, 540 interior degrees, you would divide by 5, and that would give you 108 degrees for each of the angles. A regular hexagon has 6 angles, so 720, which is the total of the triangles, divided by 6, each angle is 120. A regular heptagon has 7 angles, so 900 degrees, which is the total of the interior angles, divided by 7, each angle is 128.6 degrees. So n equals the angles, and then you can work out the amount of triangles on the inside of a shape, and that will give you the amount of degrees per corner or per angle within the shape.